Hey guys, this is problem number 6 from our lecture problem set. We've got permanganate reacting with H2C2O4, producing manganese 2 plus and CO2. First half reaction, we're going to take the permanganate and the manganese 2 plus. So, manganese is balanced. The first step is to balance all non-O and non-H atoms. That's taken care of. Next step down, we have 4 O's on the left. Balance it by adding oxygen atoms by adding water molecules. 4 O's on the right. Moving down a step. I've now, because of my 4 water molecules, I have 8 H's. Balance H's with H+. So add 8 H+ on the left. Last thing is charge. 8 plus, 1 minus, gives me 7 plus overall on left. On the right, I've got 2 plus, so that gives me 2 plus overall. I can bring this down to meet my 2 plus by adding 5 electrons. So, this is my balanced first half reaction. Now I've got my second half reaction. My second half reaction takes H2C2O4, produces CO2. I'm going to start off balancing my carbons. 2 carbons on the left. By putting a 2 coefficient out front, I can get 2 carbons on the right. Next step is to balance the H's. I have 2 on the left, but none on the right. So jumping down, I can balance this by putting 2 H pluses on the right-hand side. Balance H's by putting in protons. I now have a balanced second half reaction, but we have a little bit of a discrepancy. Second half reaction releases 2 electrons. First half reaction only picks up 5 electrons. So we've got 5, we've got 2. Just in the first problem, we need to find common ground. So, in finding the least common multiple of 5 and 2, we're going to reach 10. Take the first reaction, multiply everything by 2. We'll get the reaction here. Take the second half reaction. We're going to multiply by 5 to get this up to 10, and that results in the reaction shown here. So we now need to combine our reactions. 10 electrons, opposite side of the arrow so they cancel. 16 protons, 10 protons. So I can cancel the protons on the right. I'll be left with 6 on the left-hand side. 2 permanganates. 5 H2C2O4 produces 10 CO2s, 2 manganese 2 plus, and 8 waters. But this problem was a little odd. We balance all of these with respect to balancing in acidic solution. But this problem specified balance in a pH of 14 or a basic solution. So I need to add just enough hydroxide to neutralize my H+. So if I add 6 OH minus to 6H plus, I can neutralize those and make 6 waters. I'll then have 6 waters on the left, but 8 on the right. So we'll need to cancel out all 6 waters on the left, leaving only 2 waters on the right. In our final reaction, we're left with a completely neutralized OH minus and H plus on the left, which canceled, leaving only 2 waters on the right-hand side, and a completely balanced first and half reaction that have been merged. No electrons are left over in the overall reaction. All the atoms balance, and the charge balances, so things check out. This is the answer to number 6 in the lecture packet for balancing redox reactions.